Yo, hi. So, as promised in the last part of electrolysis, we have discussed about examples of we have discussed about many topics, right? This time we will be discussing about a few examples of electrolysis. Examples of electrolysis. Point wise, I will break each one down to you very explicitly and nicely. So, let's start. Number one is electrolysis of electrolysis of molten lead bromide PbBr2 solution. Molten lead bromide solution. So let's discuss in points. Number one, who is the electrolyte here? The electrolyte we have here is molten PbBr2. The electrolyte we are having here is molten PbBr2. What is the temperature? The temperature is above 380 degree Celsius. Okay, the melting point of PbR2 is basically maintained by continuous heating on a burner. So this is my temperature. Then we have the electrolytic cell. Electrolytic cell जो voltameter होता है, we are using silica. Crucible is made of silica. Okay. Why is it made of silica? Because silica is non-reactive. That is why it's made of silica. Okay. Then it can withstand high temperature. Non-reactive, non-conductor of electricity. Silica crucible. Okay, so it's non-reactive. It can withstand a high temperature, and it's almost a non-conductor of electricity. So silica is used. Electrolytic of voltameter is made. Electrolytic cell of voltameter cell is made of silica. Okay, so solid lead bromide. Why are we using not molten lead bromide? Because solid lead bromide is not a conductor of electricity. Why? Because of the absence of free ions. Okay, but because it's held by electrostatic forces of attraction, but when we are melting it, it gets discharged, and that's how it works. So we have the electrolytic cell also. We are using silica. Now coming to the electrodes. We are using a graphite cathode and a graphite anode. So cathode, anode, both are inert. Cathode and anode are inert. Made of graphite. Both are made of graphite and both are inert also. They are connected to the copper wires by the ends of two batteries. Okay. Number 5, we can actually come to ions that are present. It will obviously be Pb2 plus and Br minus. Okay, lead ions and bromide ions. Okay, then electrode reactions. Let's discuss the separate electrode reactions. So what happens is basically when we are putting the electrolytes at molten lead bromide, and when we are passing electricity through the molten lead bromide, when current is turned on, the positive lead ions are first there. Okay, so lead ions and Br minus ions, they are held by electrostatic force of attraction. Now electric current will break this electrostatic force of attraction, and what we are getting is Pb2 plus and Br minus. Now Pb2 plus will definitely go to the cathode, right? So at cathode, Pb2 plus will get discharged, right? And what will Pb2 plus try doing? Pb2 plus will try, what will it try doing? Yes, it will try becoming neutral. So Pb2 plus has lost 2 electrons to become cation, so it will gain 2 electrons to become Pb. This is the reaction that will be happening there. Now at anode क्या होता है? ठीक है, तो Pb2 plus जो होते हैं वो they take 2 electrons each lead ion will take 2 electrons and they will become neutral lead ions, whereas the negative bromide ion, it will migrate towards the anode. Okay, and it will lose 1 electron. To the anode, come in contact with the anode, give an electron each, and it will become bromine atoms. But guess what? Bromine cannot remain alone, right? So 2 bromine atoms will combine and they will form Br2. Okay, so we can say overall ionic equation also you're given to write. you can write, I'm sure, that PbBr2, that is definitely a liquid. It will break down to give me Pb plus Br2. Pb will be in the PbR2 will be in the form of gas. These are the bromine vapors, and lead will be again in the form of solid. Okay, so this is going to be my overall reaction, and I hope you can write the electrode reactions also. That is Pb2 plus will lose the it will gain the 2 electrons it's lost and will to become Pb, neutral lead atoms, and Br minus will lose the 1 electron it is gained to become an ion to become Br, and Br plus Br will combine to give Br2 plus. Now I've already told you why we are using silica, right? And I've already told you this one, that we are using silica because silica is non-reactive. It can withstand a very high temperature, and it's almost a non-conductor of electricity. Thus silica's crucible is heated slowly from outside. And we've also said that molten lead bromide cannot be used because molten lead bromide is used because solid lead bromide is a non-conductor of electricity due to the absence of ions. Okay, because there are electrostatic forces of attraction. And why are we using a graphite? Okay, then anions become free when lead bromide is infused to molten state, hence crucible is heated from outside. Then why are we using a graphite anode? This question can come. Why graphite? Graphite एनोड. वाई ग्राफाइट एनोड? एनोड पे क्या बन रहा है बोलो? एनोड पे Br माइनस जाता है, एनोड पे रेडिश ब्राउन ब्रोमीन वेपर्स बनते हैं, राइट? सो बेसिकली ब्रोमीन वेपर्स आर वेरी रिएक्टिव. ओके, एंड एनोड graphite anode is preferred to other inert anodes or other inert electrodes are also there, like platinum. But platinum is not taken. Graphite anode is always taken because it remains unaffected by reactive bromine vapors. It remains unaffected by reactive bromine vapors. Okay, this is it. Now what is the observation? Observation at cathode. At cathode we will get the gray metallic lead deposit, क्योंकि यहाँ पे तो lead बन गया. Gray metallic lead at cathode, and at anode हमें क्या मिलेंगे? Reddish brown bromine vapors. Reddish brown bromine vapors. Reddish brown bromine vapors, or you can say dark reddish brown bromine vapors evolved at anode, and at cathode क्या मिलेगा हमें? Silvery grey metallic lead formed at the cathode. Okay, so molten PbBr2 का तो हो गया, and it's this easy. देखो फुल एक पेज में हमारा निपट गया. It's easy. Graphite electrode क्यों यूज़ होता है? बच्चा graphite electrode is used because graphite electrode is preferred. Graphite anode is preferred to other inert electrodes like platinum because graphite anode remains unaffected by the reactive bromine vapors. Now let me come to the electrolysis of acidulated water or acidified water. Electrolysis of acidified water, और यहाँ पे भी हम इनर्ट इलेक्ट्रोड ले रहे हैं, बट ग्राफाइट इलेक्ट्रोड नहीं ले रहे, प्लैटिनम इलेक्ट्रोड ले रहे हैं. अच्छा, why are we not using pure water? Why acidified water? Because pure water is a poor conductor of electricity due to the absence of free mobile ions, and by the addition of few drops of acid, what happens is the ions in water dissociate. Okay, the water dissociates into ions, free mobile ions, and becomes a conductor of electricity. Okay, that is why using platinum electrodes. Let us quickly do this also. This is also very, very easy. Point wise you will do like we did for PbBr2. Number one, the electrolyte. Electrolyte is acidified water. Acidified water, that's going to be my water plus dilute H2SO4. Why did I add dilute H2SO4? Because it's non-volatile as compared to other acids. Okay, like dilute nitric acid, very, very volatile. Dilute hydrochloric acid, very, very volatile. Okay, this is non-volatile, so this is preferred. Okay, then what are my electrodes? My electrolyte is this. What are my, okay god, my electrolyte is acidulated or acidified water by the addition of drops of dilute H2SO4 into water. Then what is my electrode? my electrode is going to be platinum foil. Platinum foils are basically inert, okay, and they're connected by copper wires. These graphite and platinum, these are the two inert electrodes we are studying, and copper, nickel and silver, these are the three active electrodes we are studying about in this chapter. So see, platinum foils is basically inert and it's connected by copper wires to the two terminals of a battery. Now we are dissolving, see, self ionization of water हमें पता है, right, and self ionization of water, तो वो भी हमें consider करना है. Ionization of water. Ionization of water. Water in pure state consists of compounds, okay, consists of molecules. Water in pure state has only what? Molecules, because it's a non-electrolyte. As I said, that distilled water is a non-electrolyte. Why? Because it's a polar covalent compound. No, it's a polar covalent compound and it can form ions then. But in its pure state, it's non-electrolyte. It can form ions. Gandhi handwriting hai, but don't mind, go on the content and not the handwriting. So it's a polar, oh my god, I wrote the wrong spelling, and can form ions. It has the capability to form ions, okay, when traces of dilute sulfuric acid is added. Why? Dilute sulfuric acid catalyzes the ionization. यहाँ पे ionization होता है, dissociation नहीं, because water is a polar covalent compound and there's a formation of the positive and negatively charged compounds, ना कि there's a dissociation of the already present ions, right? So dilute H2SO4 basically catalyzes the ionization of water. It catalyzes the ionization of water, okay, and hence electrolysis in acidified water is considered as an example of catalysis. So we can say it's an example of catalysis. Why? Because acidified water is used, dilute sulfuric acid is added so that the dissociation of water into ions, so that water can conduct electricity, is easily done. Now यहाँ पे that is what we are doing, okay. Okay, with that being said and done, let me move to the next part. Yeah, let's just do the next part. So you understood why the electrolysis of acidified water is considered, a classic example of catalysis, because we are adding this, okay. So this is considered electrolysis because, so electrolysis of acidified water is considered as an example of catalysis, okay. Now let's go to ionization of acidified water. Okay, let's start with ionization of water, which I've been putting off since a long time. So which point is this for? Ionization of water. Ionization of water. Water in pure state consists of molecules, as I told you. Oh no, not this. Ionization of acidified water. So ionization of water to मैंने कह दिया. Now coming to ionization of acidified water. How will this ionize? So water though is water. It will ionize like it does. H2O, H plus OH minus. H2SO4 H plus 2 SO4 2 minus. This is the ionization of acidified water. So we can say what are the ions present in the solution. We have the H plus ion, we have the OH minus ion, when we have the SO4 2 minus ion, right? And what are the particles present in the solution? When we are saying that what are the particles, we will also include water. Okay, so what are the ions? We have hydroxyl ion, we have hydrogen ion, and we have sulfate ion. And what are the particles? Hydroxyl ion, hydrogen ion, sulfate ion, and water. Now coming to reaction at cathode, at anode. Okay, so 5. First, let us do at cathode. ये अलग पेन से होगा. Okay, at cathode. अब देखो कैथोड में कौन जाते हैं? कटायंस. यहाँ पे हमारे कितने कटायंस है? एक ही कटायन है H प्लस, तो H प्लस जा रहा है. इट्स द ओनली पॉजिटिवली चार्ज आयन, सो इट माइग्रेट्स टुवर्ड्स द कैथोड. ओके, सो H प्लस माइग्रेट टू कैथोड. ओके, सिंस कैथोड इज अ रिजर्वॉयर ऑफ इलेक्ट्रॉन्स, कैथोड के पास बहुत सारे इलेक्ट्रॉन्स हैं देने के लिए, बट एनोड को चाहिए इलेक्ट्रॉन्स. ओके, सो सिंस कैथोड इज अ रिजर्वॉयर ऑफ इलेक्ट्रॉन, H प्लस जो है वो कैथोड से एक इलेक्ट्रॉन लेता है एंड H बन जाता है. बट H तो अकेले रह नहीं सकता, तो H प्लस H हो जाता है एंड H2 हो जाता है. Right, so this is the hydrogen gas is formed. Okay, hydrogen gas is then formed. So since the cathode is a reservoir of electrons, a hydrogen ion gains one electron and it becomes a neutral hydrogen atom. And hydrogen atoms, they again combine to form a hydrogen molecule, which is hydrogen gas. This is my anode reaction. Now let me come to at cathode. At anode. This is my cathode reaction at anode. Anode में क्या क्या anions है? They will go, hydroxyl is there and SO4 2 minus is there. Well, so we can say that SO4 2 minus and OH minus, both of them will migrate towards what? Both of them will migrate towards my anode because they are anions. Anions go to anode. So both of them will migrate towards anion, but one of them is going to get discharged, right? OH minus being lower on the electrochemical series will get preferentially discharged. तो ये भी क्वेश्चन आता कि who will get preferentially discharged? OH minus will be the one who will get preferentially discharged because why? It is lower in EC series, lower in electrochemical series. Preferential discharge I had taught in the previous lecture. So what happens is OH minus जो है वो तो एक अनायन है, मतलब वो एक इलेक्ट्रॉन गेन किया है, बट हमारे एनोड को चाहिए, राइट? इट वांट्स. सो व्हाट आई विल डू इज आई विल क्विकली make the OH minus lose one electron and it will become OH, right? Now OH also cannot live alone, so OH will combine with themselves. Okay, so OH minus loses one electron to become neutral OH, but the combination of OH is also there, OH plus OH, that will give H2O plus O. O again cannot live alone, so O plus O, O2. This is my reaction at anode जो कि मैंने पहले दिखाया था. Right, now SO4 2 minus भी गया था, right? SO4 2 minus also went to the anode, but H plus ion got SO4 2 minus migrated to the anode also. Wait, just wait. Since SO4 2 minus is migrated to the anode and H plus ions has been discharged, the concentration of sulfuric acid will decrease at the cathode. What did I just say? Try to process it again. Since SO4 2 minus गया ना anode में? Yes, गया. But what just happened is H plus ions got discharged, right? H plus ions got discharged at the cathode. But SO4 2 minus also went to the anode. So SO4 2 minus was also there in the anode. But then the concentration of sulfuric acid will decrease at cathode. Okay. So we have sulfuric acid. Sulfuric acid concentration cathode pe, it will decrease because cathode it is producing H plus ions, right? H plus ions it is producing, and SO4 2 minus also is migrating towards anode. H plus ions is also being discharged from the क्या बोलते हैं cathode. So concentration of sulfuric acid will decrease at the cathode. Okay, now At anode, what happens is the discharge of OH minus, as I told you, it disturbs the ionic equilibrium of water, and in order to maintain the ionic equilibrium, water itself, it goes ionized. Okay, and the excess of H plus ions thus produced, and SO4 2 minus ions increase the concentration of sulfuric acid at anode. So at the cathode, sulfuric acid concentration decreases. At the anode, sulfuric acid concentration increases. That is what happens, right? I hope you've understood what I'm trying to say. So just let me write it down quickly.
ডেটটা কিন্তু আজকে পড়কে ডেটটা দিয়ে রাখবি, তাহলে কোয়েশ্চেন পেপারটার সাথে অ্যাটাচ করে দিয়ে দিবি নেক্সট মানডে। ঠিক আছে।
ম্যাম তুমি কি বলবে একবার বলবে? তো এখন জয়েন করলাম।
সিনিটা বললাম যে এই কোয়েশ্চেন পেপারটার মানে এই কোয়েশ্চেন পেপারটা আজকে পুরোটা আমি তোদের দিতাম, বাট দুপুরবেলা বৃষ্টি হলো, পুরো ওয়াটার লক হয়ে গেছিল পুরো, প্লাস আফটারনুনের ক্লাসটা বৃষ্টির জন্য ওরা কেউ করেনি, অনলাইন করেছে, তো ওই জন্য আমাকে চেঞ্জ করতে হলো তোদেরটা অনলাইন। তো ওই ফাংশনাল গ্রামারের পার্টের কোয়েশ্চেন পেপারটা আমি পাঠাইনি তোদেরকে, জাস্ট আনসিন পার্টটা পাঠিয়েছি, এটা তো আর কোয়েশ্চেন কপি করতে হয় না, এটা করে রাখ। কোয়েশ্চেন 5টা নেক্সট মানডে আমি যখন কোয়েশ্চেন পেপারটা দিয়ে দেবো, ওটার মধ্যে আনসারটা লিখে আমায় দিয়ে দিবে।
আচ্ছা,
আর আজকে ডেটটা লিখে করবি যাতে বুঝতে অসুবিধা না হয়, এটাই বললাম।
আচ্ছা,
স্টার্ট করে দে।